Okay, welcome to session 2 of Mathematical Methods Orientation. Again, the theme of calculus continues, and a review from last session, then the derivative of y dash is cos of x, the derivative of y is negative sine of x, the derivative of y is 1 on cos squared of x, or sec squared of x, using the alternative name for 1 on cos. The derivative of e to the x is e to the x, and the derivative of log base e of x is 1 on x. We also looked at the chain rule, and the chain rule said that when we have something inside, then I make that equal to u, which is 3x, which means that u dash equals 3, and y equals the sine of u, so y dash equals the cos of u. And looking at dy dx, it's going to be dy du times du dx, which will be cos of u times 3, which is 3 cos of 3x. If u equaled x squared minus 1, then u dash equals 2x, and that y equals u to the 5, so y dash equals 5u to the 4, which means that dy dx is going to equal 5u to the 4 times 2x, which is 10u to the 4. And lastly, u equals the cos of x, so u dash equals negative sine of x, y equals e to the u, y dash equals e to the u, so dy dx will equal e to the u times negative sine of x, which is negative sine of x e to the cos of x. Now that we've seen a few of these, I reckon there's a shortcut where I can go from here to there, because it's always the derivative of the sine, which is cos of u, then the derivative of the inside, which is 3. The derivative of all of this, which is 5u to the 4, times the derivative of the inside, which is 2x. And the derivative of e to the cos of x is e to the cos of x, times the derivative of the inside, which is negative sine of x. So I think there's a little shortcut that we can use for the, for example, y equals 3x squared plus 5 to the power of 4, then y dash will be the derivative of the whole, which is 4, times that bracket to the power of 3, times the derivative of the inside, which is 6x, which is going to give 24x, 3x plus 5 to the power of 3. This abbreviated form of the chain rule is what I'm going to use in today's session. And today's session is brought to you by the product rule and the quotient rule. The product rule is a rule that we can use to take derivatives where we have x's in terms that are being multiplied with each other. So u is an expression with an x and v is an expression with an x, and the derivative of u times v is u times the derivative of x plus v times the derivative of u. So I'm going to call u equal to x squared and v equal to x minus 1 to the power of 4. So u dash is the derivative of x squared, which is 2x, and v dash is the derivative of this, which I have a chain rule. So I'm going to use the shortcut. 4 times all of that to the power of 3, which is x minus 1, and the derivative of the inside is 1. So dy dx is going to equal this times this, so 4x squared x minus 1 cubed plus this times this, 2x x minus 1 to the power of 4. And I can see that I have some common factors to factorise. I can take a 2 because there's a 2 in the 2 and the 4. I can take an x because there's an x in the x squared and the x. And I can take x minus 1 to the power of 3 because I have 3 of them here and 4 of them there. And that's going to give me a 2x as part of the first expression, plus the 2 and the x is gone, x minus 1, and that gives me 2x, x minus 1 cubed times 3x minus 1 as being my final answer. And you can see both of those examples done for you. Does this one look like? U equals 4x squared, u dash equals 8x, v equals the sine of 2x, v dash. So we have a chain rule. So I'll treat it as the shortcut. The derivative of sine is cos of 2x, and the derivative of the inside is 2. So dy dx is going to equal this times all of this. 4 times 2 is 8, x squared cos of 2x, plus 8x times sine of 2x. And to take out common factors, I've got an 8 and an x. Outside of x, cos of 2x plus sine of 2x. Done. And what might this one look like? U equals e to the x, u dash equals e to the x, v equals log base e of x, v dash is the derivative of log base e of x, which is 1 on x. So dy dx should equal this times this, which is 1 on x, e to the x, plus e to the x log base e of x, and we have a common factor of e to the x, 1 on x plus log base e of x should be the answers, and all of them are completed. Last example that I'll do, but of course I've got all the work solutions, is this third one. U equals x to the 4, u dash equals 4x to the 3, v equals 5x minus 1 to the half, v dash equals a half, 5x minus 1 to the negative a half, and the derivative of the inside is 5, that's 5 on 2, 5x minus 1 to the negative a half. Piecing all that together, dy dx should equal this times this. So 5 on 2, x to the 4, 5x minus 1 to the negative a half, plus 4x cubed, 5x minus 1 to the positive a half. Okay, I'd like to take out a half to get the fraction as a common factor out the front. 5 and 4, there's no common factor. X to the power of 3, 5x minus 1 to the negative a half. Because I have negative a half and positive a half, the smaller of those two is negative a half, and that will be multiplied by. I've taken the half out, so I'm left with 5x, and I took all of that bracket out, plus I took a half out and I had 4, so that's going to leave me with 8. And I'm going to have 5x minus 1 because I had a half and I divided it by that factor to the power of negative a half. And that's the same as 5x plus 40x minus 8, which is 45x minus 8, which gives me a final answer of, where's some space? My final answer is going to be, the 2 goes downstairs, the x cubed stays up the top, this goes downstairs as the square root of 5x minus 1, and this factor here is 45x minus 8, and that's going to be my final answer. And you can see all of those there. And lastly, the quotient rule is a rule we use where we have an x in the numerator and an x in the denominator. The example here would be u is always on top. So u is going to equal 2x squared minus 3 to the power of 3. And notice we have a chain rule. So u dash will be 3 times all of that to the power of 2. And the derivative of the top is going to be 4x. So that gives me 12x, 2x squared minus 3 to the power of 2. And v is the denominator, which is going to be e to the x, so v dash is equal to e to the x. So this is going to equal this fraction, there's a subtraction. So it's important you have to start with v. So it's going to be v times u dash. So e to the x 12x 2x squared minus 3 to the power of 2 minus this times this, e to the x 2x squared minus 3 to the power of 3 all over e to the x squared. Now, I can say I have e to the 2x, multiplying the two powers together. I can take out a common factor of e to the x. I can't take a common factor of 12x because I don't have an x over here, but I do have 2x squared minus 3 to the power of 2. So I will be left with the e to the x goes to the front, 12x minus the e to the x goes, and I will have 2x squared minus 3 to the power of 1. This will simplify to this to leave e to the x. I will have 2x squared minus 3 to the power of 2, and this will be 12x minus 2x squared plus 6. And that's not 6, that's 3. And that's going to be my final answer. And that's that worked out. A couple of other examples for you to do. I've got work solutions there. And the rest of the session is the work from product rule and quotient rule. There's a sheet which is chain rule, product rule, quotient rule. There's an example from an exam question for you to complete. And I will see you at the start of next year.